I've been introduced. I'm Katie Barber. I'm head of science at St Ursula's in Greenwich. And I came at this project, first of all, because I knew Chris through having done my master's at King's. And secondly, through my slight obsession with assessment for learning, which I'll talk about in a moment. I was also interested in the idea of authentic investigations. I'd seen a little bit about the Getting Practical project previously, and so this seemed to lend nicely with that and take it a little bit further as well. Also, obviously the professional development of my own teachers. I was very keen to move on how they were using their assessments in classes and whether they were really thinking carefully about why they were doing assessments, or was it's on the scheme of work, so therefore I'm going to do this particular practical. And finally, the last one, science is more than the final exam. This one, I don't think I was thinking about it explicitly at the time. I think it's something I felt I always knew, we wanted to teach science to make scientists. We're not just getting GCSEs out of them. But I don't think I was really explicitly thinking about that as a goal until quite later on in the project. Okay, so my obsession with assessment for learning. These are my three current favourite books. I do read a lot about assessment for learning. I have been known to listen to assessment for learning podcasts. So I'm very heavily into it. I'm always looking for different ways of assessing what the students are doing in class, and more importantly, how I'm going to use that, and is that assessment actually telling me anything worthwhile? So if you are sort of a science teacher or you're developing science teachers, I started, the first one I found fantastic, just for here are some really amazing strategies, and plus it's American, so there's a lot of strategies that I hadn't already come across through my own development. And also linking in nicely, giving you a little bit of background on how you're going to use those particular strategies. And the second one, I think, has probably informed a lot of my pedagogy in the last couple of years. It's aimed more at a whole school approach to developing TLCs, but I found a lot of the strategies in there, but more importantly, the rationale behind those strategies, and then how you use them. And then not just, I've used it, okay, I've used that particular strategy, it works well for me, but reflecting on that strategy and adjusting it for the next time, I found that quite useful. And the last one, I'm only just starting now, it's moving on from the second book, but it's looking more at teachers on their own or in small groups trying to develop their particular strategies. So that's my geek moment over. And here's my students. So I come from a very high attaining school. The students are pushed very hard, they've got very high targets, and they have become level obsessed. So I'm sure I'm not alone in having students who are very much interested in getting a 7A in science. I'm trying to get them interested in being a good scientist, and they're saying, but is this on the test? Is this a 7A? What do I need to do for this? So I'm trying to move away from this particular mindset to the mindset of a scientist and the behaviours of a scientist. And particularly within the SAILS project, one of the things that I enjoyed most and I focused really hard on with my students is moving them away from the APP, so can I plan an investigation, can I draw a graph, can I do a table, all of those things obviously very important and continuing those, but the behaviours of scientists. So getting them to think about their teamwork, their collaborative working, their communication of science, making them prioritise those ideas and really think about what a scientist does on a day-to-day basis and how it is that that becomes part of what they're doing in the classroom, and how they can then sort of develop those particular skills and value those skills as much as what is on the exam paper. And that's why I called my particular slide Changing Behaviours, because one of the big things, and arrogantly to start with, I thought it was all about changing the students' behaviours, and so it's very much about changing their behaviour and changing their mindset in going into a science lesson and doing a practical. So, I started with these two practicals. We were given a series of practicals that we could get started with to get an idea of what we were doing. And these are the two that I started. So what happens when you boil spaghetti and floating fruit, which you've already heard quite a bit about. So giving them those open-ended investigations and just giving them a question, giving them a chance to develop a hypothesis and plan their investigation and go for it. And the very first thing I learnt was that when you give a student an investigation, they think, oh, I'm going to do a practical, and they turn up, they get the equipment, although they got to choose their equipment for these ones, and they just did it. And I said, so what did you find out? Even though they'd come up with a question beforehand, so I think spaghetti will get bigger or softer or whatever they think is going to happen. And then my question is, so what have you found out? Why did you do that? What's going on with that particular experiment? And it was amazing how many students sat down and thought, well, I haven't measured anything. I don't have anything to go with that. Or they said, oh, I think the spaghetti's going to get longer, but then didn't bother to measure the spaghetti before they did it. So there wasn't deep thinking about when I'm planning this, what am I actually going to be doing? How is this going to give me valid results or interesting results that I can do something with? And for me, I knew students, I mean, we've talked about it a lot already, I knew students are quite good at saying, give me a method, I will follow my method, and I will fill in your table. But I didn't realise quite how minds off they are when they're doing experiments. So it was a big case of hands-on, minds-on whilst doing these particular experiments. Oh, before I move on as well, the one thing, or one of many things that I really enjoyed with these particular experiments that we did with SAILS, with SAILS is how in the students' own context, in their own zone of proximal development, so bringing it back in, so these are ideas that they can work with. Everybody knows about spaghetti, everybody's boiled spaghetti, everybody has some idea about objects floating and sinking. A lot of the activities we did were bringing those things very much into a context that they understood. For understanding context, one of the best practicals I did was the rates of reaction one, with the vitamin C tablets. And a person, I particularly really enjoy rate of reaction in chemistry, probably because I'm a maths head, but the students had never picked up on my enthusiasm quite as much as when they did with the vitamin C tablets. And suddenly, I had a year 11 class who were a little bit, these exams are going to happen, I'm sick of GCSEs, suddenly really enjoying a practical, which we then repeated through 3 lessons, because there were so many learning gains to be made out of that particular investigation. Okay, so learning for me. So I started off thinking about how the children need to change their behaviours, but what did I need to do to change my behaviours? One of the key ones was zip it. Don't give them too many pieces of information. You're so used to, and even when you think, I'm going to do an open-ended investigation. I'm going to tell the kids, just get on with it. Here's your vitamin C tablets. Go and find out what happens if you change the surface area. However, teach ahead on, I need them to know. I need them to know that the greater the surface area, the faster the rate of reaction. And holding on to that information, and holding on to the best way to plan an investigation. Oh, have you measured? Or have you checked that? What are your control variables? That's not going to work because I know you need to control this. Sitting back and letting them learn that for themselves and coming through with guided questions. So why are you doing that? Why have you chosen that particular value? Or have you chosen value? Or is this just a random, I've done it without any thought process? So that was definitely a learning moment for me. And as I go on to next, the assessment, I tended to head very heavily towards the types of questions that I was asking the students and listening to their answers and moving them. Different groups all started to do slightly different things within the lesson. So it was a very different learning journey for the different students. Okay, now I thought I was quite good at being very involved. But yes, I've read loads about info. I'm very, very involved in where the children are and moving them on and having an authentic science journey. But I didn't realise that I was as programmed as the children in recording levels, recording where are they at, what's going on. And I have to say, sitting through this project, a lot of the time, I wanted to write something down. We were talking about assessment, so how have the children moved on, what's going on? And I desperately wanted, and because I know my school wants me to have this record as well, where are they now? What have I written? What's the number or the letter that represents where they are at now? And so I had a disconnect in myself. And I was thinking, yes, I'm asking them questions, I'm talking to them about how they're improving, how they're moving on. However, there was still that drive inside me that I've been trained to be like for so long. I needed to have numbers written down. And so moving away from that, making a big difference in myself and saying, actually, it's okay to be looking at their journey. So it's individual students' journeys, and what we're really interested in is how they progress, what they moved on to, and have they developed these particular skills, as opposed to, do I have a number that arbitrarily maybe doesn't quite represent what skill they're actually at the moment. So, when we first started, and some of the experiments that we began with actually came with rubrics, and we experimented with different rubrics. This particular style of rubric we moved away from fairly quickly because it's got 3 levels, and everybody grades himself in the middle. I'm not awful, I'm not brilliant, I'm in the middle. So we looked at 4 rubrics, 4-level rubrics as well. And for some of them, they worked quite well. Defining our own rubrics, especially based on our own classes and knowing where they're at, became more effective. And then I think, for me personally, with rubrics, what I found most effective was the student's definition of where they are. And I find that I learn as much about what they understand of a particular concept through their definitions of what a good one looks like, what a mediocre one looks like, as when they're doing the activity themselves. So what they define as a very high quality planning compared to the lower 3 levels of planning, that also tells you very specifically what their ideas are about particularly, and do they have a good understanding of what that's going on, what's happening with that one. I've also now, as I was saying before, the majority of my assessment in the classroom is through questioning with students. So I find that they've moved on really well through having conversations with them about, so why have you made that particular decision, what's happening there? Probably one of the best examples I had of that is we did one called the top wing buses. So the children had an opportunity to investigate putting the masses at different heights, and so what's sort of the distribution of mass, so the centre of mass idea through the idea of a bus, and giving them a real world context. And we had a funny video, a real video of them testing buses back in the 70s, 60s, 70s? Yeah, long time ago. So testing the buses, and actually, I don't know if you've seen it before, definitely worth checking out on YouTube, taking members of the public, filling up buses, and making them do really tight U-turns, and seeing if the bus turned over. Kids found this horrifying, but with really nice setup for the investigation, and they spent quite a lot of time changing their different designs, and they planned it beforehand. They brought their own materials in, they decided exactly what they wanted to investigate. They found it very difficult to define the independent variable for that one, but really changing, constantly changing their ideas, and they quite enjoyed that. And for a physics practical, everyone be down on physics. For a physics practical, they got very, very heavily involved in that one. It was highly motivating, and their level of understanding of centre of mass. There were a lot of misconceptions at the time, which I dealt with more through questioning than through definitely saying this is not the right way, but getting them to develop their own ideas. And also knowing that if they can justify what they're doing, then you've got a really strong idea of whether they understand what they're talking about. So, passing it on to my department, I found that this is the wrong way. Me saying, this is a great thing, I'm doing it, I'm really enjoying it, you should really have a go at this. Very surprised that not many people took it on or attempted it at all. And then reflecting on my own progress through this particular project, I didn't get it to start with. It took me lots of practice and reflection and talking with other people about what was happening to really get an idea of what's going on. So my next steps are this. I'm going to choose one member of my staff, and through one-on-one coaching, mentoring, talking about it, but more importantly, having them in the classroom with me, because a lot of what happens in SAILS happens within a 1 metre radius of me. So I'm going around having a conversation with the student, and they're learning, and I'm learning from them, and so having a partner walking around with you and getting an idea of what's going on, and then me going back to the classroom and them trying it, and we're talking about it, a lot of my main gains was talking to the King's researchers after them being in lesson and talking about it and really reflecting on that idea. So that's my idea for how I'm going to spread it around the department. Having that conversation with one colleague, getting that colleague on board, having a conversation, developing that practice in them, and then moving on so that we then spread that on and we dominate that through the department. And I think that's going to be a much more successful way of being able to spread this particular pedagogy. So, this much I know, Guardian, this much I know. This type of pedagogy will unearth a flood of misconceptions, and if they're dealt with effectively, rapid gains are made. So dealing with them as they're coming up, and actually those misconceptions, students learn so much better from developing their own mistakes and coming through it that way. Worry about the journey, not the GCSE results, because the real learning occurs at the interface of content and inquiry when they come together and the students are applying them together. And finally, this is about changing teacher behaviours as much as students' behaviours, and might be best effected through one-on-one coaching and learning discussions between colleagues after experiencing lessons together, and that's where I'm going next.